Most planets seem to tell a simple story from far away. A cratered world looks dead. A smooth world wrapped in clouds hides its surface. A giant planet advertises its power before a single instrument arrives. Mercury looked like the easiest case of all. Small, scorched, ancient, and quiet. Then a magnetometer flew past it and found something that did not belong there. Mercury was not simply carrying a magnetic field. It was carrying one that refused to match the planet everyone thought they understood. This is the story of Mercury's magnetic field. It is not a giant shield like Earth's, not a miniature copy, and not a fossil frozen into ancient rock. It is a weak, living magnetic engine inside a planet that should have had very little left to say. The deeper scientists measured it, the stranger the map became. Because Mercury's magnetic north was not simply tilted, the entire dipole appeared shifted hundreds of kilometers toward the planet's northern hemisphere. The first clue arrived in 1974 when Mariner 10 flew past Mercury and returned a result that sounded almost impossible by definition. Mercury was the smallest planet. Its battered surface looked ancient, if appearances revealed what lay inside. Mercury should have resembled the Moon far more than Earth, a cold, rocky world with a silent interior and no global magnetic personality. Instead, the spacecraft found something standing against the solar wind. It was not just empty charged particles flowing past a dead rock. They bent around a small magnetosphere, a magnetic bubble surrounding the planet. Mercury was not simply reflecting sunlight. Something deep inside was organizing charged particles into a coherent magnetic structure. That discovery created more uncertainty than certainty. A magnetic field can exist for more than one reason. Perhaps Mercury's crust had been magnetized billions of years earlier and was preserving an ancient memory. Perhaps the relentless solar wind, striking the planet at close range, created electrical effects that only looked internal. Or perhaps Mariner 10 had simply seen too little. The spacecraft made only brief flybys and observed only part of the planet. The measurement was convincing enough to break the old assumption, but not complete enough to reveal the machine behind it. A magnetic field cannot be seen directly. It has to be reconstructed from its effects. Imagine standing outside a locked factory, trying to understand the machinery inside by listening through the walls. Mariner 10 had heard the rhythm. It still could not see the engine. For decades, Mercury remained exactly that contradiction. It was too small to behave like a planet powered by an active dynamo, yet too magnetic to be dismissed as completely dead. The planet itself never changed, only its meaning changed. Those ancient craters stopped looking like proof of silence. They began to look like camouflage. When Messenger entered orbit around Mercury in 2011, the mystery did not become simpler. It became far more precise. Unlike a flyby, an orbiter could return again and again, measuring different regions, separating Mercury's own magnetic field from the constantly changing solar wind, and turning scattered observations into a global map. The old question disappeared almost immediately. Mercury clearly possessed a magnetic field. The real question became why that field looked nothing like the easy explanations predicted. Mercury's magnetic moment was tiny compared with Earth's, at the surface. The field was only a faint version of what an ordinary compass experiences on our planet. Yet it remained organized enough to resemble a classic dipole, the familiar bar magnet pattern with a north and south pole. That should have simplified the investigation. Instead, it made the contradiction even harder to escape. A reasonable expectation was that the dipole sat near the planet's center and leaned slightly away from the rotation axis, much like Earth's magnetic field. But Messenger measured something far more specific. Mercury's magnetic axis was almost perfectly aligned with the planet's rotation. The tilt was remarkably small. The real surprise lay somewhere else. The effective center of the magnetic field was displaced northward by roughly 1/5 of Mercury's radius. Picture placing a perfectly upright bar magnet inside a planet, then discovering that the best mathematical fit is not centered at all. The entire magnetic engine appears shifted toward the north. That single result changed the investigation. A tilted field might have reflected ordinary complexity. A weak field might have suggested a fading dynamo. But a weak, nearly upright field that was also dramatically displaced demanded something far more specific inside Mercury. It was like opening a clock, finding it still ticking, then realizing half its gears were hidden behind another wall. From that moment forward, every explanation had to pass the same series of tests. It had to generate a field weak enough to match Mercury. It had to keep the magnetic axis almost perfectly aligned with the planet's spin. It had to push the entire magnetic geometry northward without creating patterns Messenger never observed. And it had to accomplish all of that inside a planet only about 40% wider than Earth's moon. The old explanations began falling away one by one. A fossil magnetic field preserved in the crust could explain ancient magnetization, but it struggled to account for a present-day magnetosphere behaving like an active planetary dipole. An Earth-like dynamo could keep the field alive, but most versions naturally produced fields that were stronger, less symmetric, or nowhere near as dramatically displaced. The solar wind certainly mattered. Mercury orbits so close to the Sun that its magnetic environment is constantly compressed and reshaped. But outside forces alone could not generate the stable global pattern repeatedly measured around the planet. The list of possibilities kept shrinking. Mercury almost certainly needed a liquid metallic core that was still moving. That conclusion alone surprised planetary scientists. Small worlds cool quickly. They are expected to lose internal heat, solidify, and shut down long before larger planets. Yet Mercury appeared to have escaped that fate. But simply having a liquid core was no longer enough. The magnetic engine itself seemed to be hiding behind another layer. One of the strongest ideas proposes that Mercury's outer core contains a stable layer resting above the deeper convecting region. In simple terms, the dynamo may be working beneath a quiet blanket. The deeper liquid metal generates the magnetic field, while the stable upper layer filters what eventually reaches the surface. That idea solves several puzzles at once. Filtering naturally weakens the field. It can also smooth away irregular features and help explain why Mercury's magnetic axis stays so closely aligned with the planet's rotation. For a moment, the pieces seem to fit. Then the northward offset returns and refuses to cooperate. Producing that displacement has proven far more difficult. Some computer models recreate part of the geometry for limited periods. Others generate strong north-south differences, but also predict magnetic structures that Messenger never clearly detected. Every improvement fixes one problem while creating another. The more accurately Mercury's magnetic map has been measured, the less freedom every model has to hide inside uncertainty. This is why Mercury's magnetic field matters far beyond a single planet. Mercury looks simple because almost everything visible about it appears familiar. Its surface is ancient. It has no thick atmosphere. It is covered with craters that seem to tell a complete geological story. The magnetic map says otherwise. The planet's most important feature may lie in a place no camera can ever photograph. Somewhere beneath that scarred crust, molten metal, chemistry, heat flow, and planetary rotation interact in ways the surface never reveals. The magnetic field changes the meaning of Mercury's entire environment as well. Because the dipole is shifted north, the planet does not shield both hemispheres equally. The solar wind does not encounter a balanced magnetic shell wrapped neatly around the globe. Instead, it strikes a lopsided magnetic system compressed toward the sun and opened more easily in some regions than others. The offset is not just a number buried inside a scientific model. It determines where charged particles reach the surface, where space weather strikes more directly, and where Mercury's interaction with the sun becomes fundamentally uneven. In other words, the displacement is something the planet experiences every second. That may be the most remarkable part of the entire discovery. Mercury's greatest secret is not hidden beneath clouds or buried below an ocean. It is written into the empty space surrounding the planet. The surface resembles a dead archive. The space above it behaves as though the planet still has a pulse. Yet the pulse refuses to become simple. If Mercury's core remains active, why is the field so weak? If the field is so weak, why is it so orderly? If it is so orderly, why is almost all of it shifted toward the north? Every answer closes one path while exposing another restriction. The investigation does not move cleanly from ignorance to explanation. Every similar times, far more important than simply confirming Mariner 10. The original discovery answered one question. Mercury has a magnetic field. Messenger replaced it with a far more difficult one. Why does Mercury possess a magnetic field, unlike almost every straightforward prediction planetary science would have made? A planet that looked dead concealed an active interior. A tiny magnetic field demanded an unexpectedly complex engine. An almost perfectly aligned magnetic axis revealed one of the largest dipole displacements found anywhere among the terrestrial planets. And a map drawn entirely from invisible forces became more revealing than every photograph of Mercury's cratered landscape. The final lesson is not that scientists have no explanation. Mercury forces every explanation to satisfy too many truths at the same time. The field must be alive. It must be weak. It must remain almost perfectly aligned with the planet's rotation. It must be displaced far toward the north. And it must all emerge from a small rocky world that reveals almost nothing about its interior directly. No drill has ever reached Mercury's core. No camera can watch its liquid metal flow. Everything we know comes from the magnetic signature the planet leaves behind in space. Like the shadow of hidden machinery buried thousands of kilometers below the surface. Mercury no longer means what it once did. It is no longer simply the sun's smallest neighbor, or an ancient cratered leftover beside larger, more dramatic worlds. Instead, it stands as a warning about trusting appearances. Planetary surfaces tell only part of the story. Sometimes, the most important evidence exists where there is almost nothing to see. A planet that looked silent concealed a working engine. That engine generated a magnetic field. And when that field was finally mapped in detail, it refused to point toward a simple explanation. It pointed north, away from the planet's center, toward one of the most stubborn interior mysteries anywhere in the solar system.